Hello, I'm Chaitrali Bhoi. I'm Research Associate at IIM Bangalore Center for Digital Public Goods. Today we have Ruchi and Abhishek from IIM Bangalore's one-year MBA program's 2026 cohort. Today we are going to discuss about their proposed India's sustainability stack, which could potentially transform India's sustainability landscape with DPI approach. India is dealing with vast amount of sustainability issues in water, energy, forest, pollution, waste management and social welfare. And departments are independently dealing with these challenges. But in reality, sustainability issues don't consider these boundaries. So why do you design or proposed sustainability stack?
So to answer your question, I'll begin with a very simple idea. Sustainability problems do not exist because we lack data. They arise because we have data, but we are not able to see a fuller picture together. So in India, sustainability involves three different groups around which our decisions revolve. First is Samaj, which comprises of your citizens and communities. Another is Sarkar, which comprises of government departments and regulators. And third comes the Bazaar, where we talk about private companies, utilities and platforms. Now, each of these actors play a role in sustainability outcomes, but they act in isolations. They are siloed. So the stack which we are proposing, it is needed to connect their actions on a population scale using a DPI approach. So to answer for your question further, we will discuss about the nature of the sustainability problems. The sustainability problem is a systemic problem and not a sectoral problem. We have issues like water scarcity, energy issues, traffic congestions. They do not belong to one department. These problems arise because of the interactions between the multiple departments like water, electricity, land usage, housing, etc. But today, the water department looks only at water data. Electricity looks only at power data. So now these systems, they are optimized locally, but nobody is optimizing the system as a whole. So at India, where we have a population of around 1.4 billion people, this kind of a siloed approach might fail quietly, but suddenly it will become a crisis. So this is the kind of a gap which our sustainability stack tries to address.
What is your take on this, Abhishek?
So let us understand this fundamental gap that exists between the siloed departmental data and the integrated reasoning that is required to solve the sustainability issues. So we can look at this from a lens of Samaj, Sarkar and Bazaar. So in Samaj, which comprises of citizens and communities, so they do generate signals like water consumption, electricity consumption, waste generation and mobility patterns. They are able to see problems at the individual levels like water pollution, air pollution, issues of waste disposal. But at the level of authorities, they are being told that everything works fine. Now let us see at Sarkar, which comprises of government regulators and authorities. So they do have their own data, but the data are stored in silos. Each department owns their own data, but there is no linkage between the databases. They are able to give reports based on their sectoral data, but they are not able to address questions like why this ward is facing water shortages, where the leakages are happening, and which intervention will work the best. So their approach is generally reactive. It is not anticipatory. So now let us look at Bazaar, which comprises of private entities, MSMEs, industries. Private companies do optimize data locally, like utilities optimize their cost, platforms optimize their logistics, developers tries to maximize their built-up areas. But without a system-level view, these optimizations often create new sustainability problems elsewhere. So a sustainability stack is needed because none of these actors can solve sustainability problems alone. And in India currently, no digital infrastructure allows them to act together. Let's understand this with a simple example of urban water shortages. So many areas in a city do face water challenges, but when authorities are asked about this, they say that they are supplying enough water to all the regions. So why this discrepancy exists? So this happens because at the level of Samaj, the per capita consumption varies across the region. and also there are lifestyle changes. So because of which the water consumption is not even. The Sarkar systems are also involved in this. Electricity departments, they signal urban growth. Waste system data are indicative of population density. And the planning authorities talk much about the new construction coming up in the city. If we look at the bazaar actors, they comprise of real estate developers, construction firms, commercial establishments. So all these entities do have an impact on sustainability outcomes. Now, if you talk about the reaction of the authorities and governments, it is reactive. So whenever such crises occur, they react with, say, drilling boreholes, exploiting natural resources like lakes, building reservoirs. So that is an expensive solution, and it is quite often inequitable. So what we are missing is early integrated reasoning, like which areas are growing fastest, where the leakage is highest, and which zones are over consuming. So sustainability stack enables exactly this kind of reasoning by connecting signals across systems before any crisis occur. Now let us understand why DPI approach is essential. At India scale, the problems that we discussed cannot be solved by one new dashboard or one department controlling the entire data or using one private platform. So it requires a digital public infrastructure like identity and payments. A DPI approach ensures that data stays with rightful owners, systems interoperate using standards, and insights are shared for public decision making. And also, no single actor controls the entire narrative. So, the sustainability stack applies this DPI philosophy for sustainability governance.
Now, to summarize the entire discussion that why we needed a sustainability stack, in short, if we say that sustainability challenges are system wide, the governance today is siloed, and India needs a population scale DPI that allows Samaj, Sarkar, and Bazaar to interact each other, to reason together before this kind of a problem becomes a crisis. So, this was the fundamental motivation behind the project.
Can you walk us through your proposed sustainability stack design? What inspired you to explore this particular approach?
Key design choice in this project is the idea of stack. A stack is a multi-layered system which draws its precedence from India's experience in digital public infrastructure and forest stack, where each layer has its own meaning and a clear role. And these layers are built one over the other. So the central idea is simple. Complex sustainability problems cannot be solved by a single system or a dashboard. They require a structured, layered digital architecture. So a natural question that may come to anyone's mind is why not build a single system that can solve the entire problem? Where the answer is that sustainability governance involves very different functions like storing the authoritative data, sharing the data securely, combining the data for across the departments, analyzing the future scenarios, and finally taking the governance action. When all of this is forced into a single systems, so departments tend to resist data sharing, system can become slow and inefficient, and accountability becomes unclear. To solve this issue, India's DPI experience shows us a better way. So there are separate concerns, but we can connect them through standards.
So that is why the stack based design is essential, that which becomes the core of our project. Now I'll try to walk you through the 6 layers of the sustainability stack which we have designed in our project in a very simple term. Starting with the layer 1, which is master data systems. This is a layer where the data already exists. We are not creating anything new. Examples like water utility database, electricity database, pollution monitoring platforms, these are all maintained and owned by their own respective departments. Coming to layer 2, which is the registries, which actually is the heart of the stack, most important design. A registry is not a database, so we need to clearly demarcate the two. They cannot be confused with. It is like a control room. It does not store the data. It will call from the database from the multiple systems whenever we try to fetch some information. It will link the data using the common identifiers like asset or entity, etc., and then will produce a single consolidated view for decision making. This is actually inspired by India's DPI experience, like Aadhaar stores identity and UPI kind of orchestrates the transactions without storing money. So similarly, our registries concept, it will orchestrate the sustainability data without having any ownership to it. Coming to layer 3, which is interoperability and access. Now this layer allows the data to talk to each other safely. It uses APIs, authentications, data standards, audit logs. Most importantly, this layer ensures that the data is shared only for defined purposes. The ownership should not be lost and the misuse should not happen. Coming to layer 4, which talks about analytics and intelligence. Once these registries have created a kind of a consolidated view, analytics can answer the questions which we are looking for, like what will be the demand in 5 years, which intervention will give us the highest impact, what are the kind of risks which we might face in future. So this layer supports forecasting, scenarios and kind of optimization. So next layer is decision tools. This layer translates these insights which we have taken from all the 4 layers into usable views. For whom? For policymakers, regulators, managers, and sometimes even citizens. So these are just not the charts, they are basically your decision tools. The most important for which we have worked on these 5 layers is the governance actions and feedbacks. So these insights which we have gained, these will lead to actions like investments, regulations, improvements, corrective measures. And then finally, we will have outcomes that will be fed back into the system so that a continuous learning loop is maintained, so that our registries keep updating themselves and we are always working on an updated system. So when these systems are continuously updated, it just doesn't help for maintaining the governance structure. It also helps the private setups and the startups to innovate and actually build upon their services based on this.
Among these layers, registries are very important. Let's take example of air pollution in a city. A traditional dashboard might show that AQI levels have crossed safety limits. But a registry-based system can combine the traffic congestion data, vehicle fuel mix, industrial activity, weather and wind patterns, and the electricity demand in various regions of the city. So by linking these data sets, registry can enable authorities to answer questions like, is the pollution driven by industries, traffic or weather? Which zones contribute most to the pollution and which intervention will work the best in future? So without registries, departments argue whose data is correct. But with registries, these systems can work together and reason collectively. So this is the power of stack-based design. This design directly supports the Samaj, Sarkar and Bazaar philosophy. Samaj benefits because services become more equitable and transparent. Sarkar benefits because decisions are evidence-based and not reactive. Bazaar benefits because rules become predictable and efficiency improves. So, and there's no single actor dominates. This stack acts as a neutral digital infrastructure for public good.
Please take us through your design process. What were your key findings and what conclusions can be drawn from them?
So this project is not about writing a policy note or trying to develop a tech prototype. It was more about designing a digital public infrastructure blueprint for sustainability using a very structured and a research-based approach. So our intention was to move from the vague idea which we had that we need a better sustainability idea. It is a very open-ended kind of a statement to move towards a more clearer and an implementable system design. So we were trying to figure out how will we go about this problem and how will we actually design what we have in our heads. So we used stepwise approach. We started with the first thing that first we'll try to understand the problem in depth. What are the struggles which sustainability governance faces? We found that as we discussed earlier also, that the problem is not lack of data. It is about reasoning across the data which is available. So most sustainability systems today, they are department specific, they are backward looking, report oriented. They can answer questions like what happened last year. But what if we want to question what will happen next? What should we do differently to have some different outcomes? So at this stage, we studied India's broader DPI journey and sustainability focused efforts like Forest Stack, which demonstrated that if we have a very layered registry based systems which can support complex environmental guidance. So this helped us anchor the project to proven DPI principles instead of making it an abstract theory. Then second, we tried to map the entire sustainability ecosystem instead of focusing only on the government departments. So for this, we listed or worked around more than 40 types of actors which spanned across the same Samaj, Sarkar and Bazaar which we discussed. And we added a few more like ecological entities, water bodies, green spaces. We also worked upon the systemic entities which are like structured bodies, ESG frameworks. Now for each of these actors, we try to understand that what kind of a role do they play in the sustainability outcomes, what reports or what data do they generate or consumes, and what kind of decisions they can influence. So with this exercise, we had one thing very clear in our head, that sustainability outcomes emerge from interactions and not only with isolated actors. Then the next thing we came up was that if we are taking these actors, then how do we measure them? So we first decided to work them across the three indicators, our economic, environmental and social indicators. So we picked up these actors which can be realistically measured using the existing data systems. The key principle here which we followed was that we will not take any hypothetical indicators or the data which does not exist, or it exists but we cannot access it. So we designed a conceptual sustainability dashboard, not as a product, but as a methodology to test whether meaningful insights can be taken if the data is combined, and whether these indicators are actually supporting any kind of real decisions or not. So this exercise gave us a very important insight that dashboards alone are not enough. So these dashboards, they show outcomes, but they do not explain the causes or their coordinated actions. So this was the entire reason behind the concept of registry. This led us to registry.
Abhishek, what are registries and how are they different from databases?
So our key contribution to this project is the distinction between databases and registries. So we observe that many sustainability initiatives fail because they try to centralize all the data into one database or build dashboards on top of fragmented data systems. We clarified that databases store authoritative data for a single domain, whereas registries can orchestrate data across domains to support decisions. Using India's DPI experience as inspiration, we designed registries as neutral coordination layers, not owners of data. This conceptual clarity allowed us to design 6-layered sustainability stack where registries sit at the center and enable reasoning across systems. We demonstrated this through an urban water use case. To ensure the idea is not theoretical, we demonstrated it through an urban water sustainability use case. So instead of looking only at water supply data, the registry conceptually integrates water production and distribution data, electricity consumption as a proxy for growth, waste generation as a proxy for population density, mobility patterns indicating urban intensity. So this allows decision makers to anticipate water stress, identify inequities, target leakage reduction, and plan infrastructure proactively. So this use case showed us that stack design is feasible using existing data and without the need of creating any system from scratch. We concluded this with a governance model, which includes who owns registries, who supplies data, who take decisions, and how feedback and redressal mechanisms are integrated. On a personal note, this project was undertaken alongside a full-time intensive MBA program. At the beginning, there was uncertainty about whether such a large-scale DPI concept could be meaningfully designed within an academic project. However, through structured thinking, iterative refinement, and guidance, the feasibility of this approach became clear. In summary, what we have done in this project is diagnose a systemic governance problem, apply DPI principles, build a layered sustainability stack, demonstrate it through a real world use case, and propose a governance model for adoption. The outcome is not a final product but a scalable blueprint for sustainability governance at a population scale.
So, what do you see as the impact of sustainability stack for citizens, governments, and private sectors in short term and long term?
To understand the impact of the sustainability stack, we need to understand an important thing, that this project is not about technology. It is about how decisions are taken, who benefits from these decisions, and how our society responds to these decisions over time. So, to understand the true impact of this sustainability stack, we need to analyze it through the lens of Samaj, Sarkar, and Bazaar. Because the sustainability outcomes, they are shaped jointly by citizens, government, markets, and public-private partnerships. So, starting with Samaj, if we see the short-term impact which this stack creates on them, is kind of a more granular service delivery. You get a kind of a prioritization of high need areas and visibility into the local environmental conditions. So many citizens experience a mismatch between official reports and what they actually face, the reality they live in. The stack reduces this gap and allows the data to be disaggregated to a more deeper, that is neighborhood or ward level, rather than just at the city or a state average. So in long term, the impact on Samaj is deeper. Citizens become more informed participants rather than just being passive recipients. Communities, they gain visibility into the sustainability trade-offs, and trust improves because decisions are more explainable. Now let's discuss this impact of this stack on Sarkar, which is our government departments and regulators. So in short term, it helps government to move away from static reports and delayed data, and instead it enables more situational awareness, cross-department coordination, and evidence-based policy decisions. Importantly, this happens without taking the control away from the departments. Each agency continues to own its data and decisions are taken with a system-wide view. And in long term, this impact is more of transformational. Governance shifts from reactive to anticipatory. Sustainability becomes a core planning mandate and not an afterthought. And India builds leadership in DPI based climate and sustainability governance.
Adding to what Ruchi said, this allows governments to prevent crises rather than manage disasters. Now let's look into the impact on Bazaar, which comprises of private sectors and markets. In short term, the sustainability creates efficiency gains, reduces leakage and wastage, and sets a clear compliance pathways through registries. Businesses benefit because the rules become more predictable and they are data driven rather than ad hoc. In long term, the stack enables new markets for sustainability technologies and services, data driven ESG performance, and innovative partnership models with government and communities. Private players are no longer just regulated entities, they became co creators of sustainability outcomes. Looking ahead, the sustainability stack has national and global significance as well. At national level, it establishes sustainability governance as a digital public infrastructure, just like UPI and Aadhaar. At a global level, it positions India as a leader in DPI for climate, population scale sustainability governance, and exportable digital public goods. The Samaj, Sarkar, and Bazaar blueprint ensures that this is not a top down system but a collaborative and scalable framework. In summary, the sustainability stack has a potential to transform sustainability governance by empowering citizens, enabling proactive governments, and aligning market incentives. So it shifts sustainability from fragmented oversight to integrated reasoning and from reactive response to anticipatory planning. So that ultimately is the long-term impact of the sustainability stack.
Thank you, Ruchi and Abhishek, for walking us through your proposed sustainability stack and what potential it holds to transform India's sustainability landscape with the approach of TPI. Thank you.
Thank you,
Thank you.
Chitrali.